Greetings, and welcome to this episode in the series of videos on working with remote sensing with ArcGIS Pro. This series is brought to you by AmericaView in partnership with Virginia Tech, the Virginia Cooperative Extension, and Virginia View. I'm Cherie Aukland, and I'll be your guide. This video tutorial series builds on ongoing and previous collaborations and contributions provided by the USDA NIFA through the ADVANCE project, the National Science Foundation, through the GeoTED UAS project, the Ohio State University, and the Virginia Space Grant Consortium. This video series is associated with the Remote Sensing with ArcGIS Pro 2nd Edition book. We will use Landsat 9 imagery in this series, and we'll also begin with Chapter 10. Links to resources for this video series, including free access to the textbook and to the videos for Chapters 1 through 9, are available in the video description below. Image classification is a process that sorts individual pixels based on their spectral values into informational classes or categories. Two methods for this process are unsupervised classification, which we cover in this chapter, and supervised classification, which is covered in chapters 22 through 24. Before beginning this video, please see your text for a detailed introduction to unsupervised classification, including spectral homogeneity, spectral distance, and classes of homogeneous spectral identities versus informational classes. In this chapter, we'll complete an unsupervised classification of a Landsat 9 image. We'll determine the land cover class associated with each spectral class, and we'll create color-coded informational classes according to this table that you see here. Finally, we'll calculate the percentage of the total area for each of the informational classes. Here I have begun a new project and added the 6-band composite image created in Chapter 15. Set your workspaces and eliminate background values. As usual, there are multiple ways to complete an unsupervised classification. One method is to use the classification wizard from the Imagery tab on the ribbon. However, this creates an image only usable in the current map document, so we'll use a different method to set us up for using the image in Chapter 25, Accuracy Assessment. Let's go to the Analysis tab, Tools, to open our geoprocessing pane, and let's search for classification. We want ISO Cluster Unsupervised Classification. Under Input Raster Bands, we'll choose the 6-band subsetted composite image. You could choose individual bands here if you don't have a multi-band composited image. For output, we want 4 different informational classes, but the number of classes here refers to the number of spectral classes. Our image has over 65,000 different pixel values. Each category of our informational classes, water, agriculture, urban, and forest, will consist of a range of spectral values. Let's set this number to 25. For real applications, 50 spectral classes should be used, if not more. See your textbook for further discussion on setting this value. We'll accept the output classified raster name, and we'll leave the sample interval and minimum class size values, which refers to the smallest number of pixels the software should place in one spectral class. Then let's run the tool. Because the number of classes was set to 25, there are 25 unique values in the symbology of the new image and contents. These colors have been randomly assigned to the new image of homogeneous spectral classes, not informational classes. Now we have to determine which of these spectral classes should be assigned to each informational class. All 25 spectral classes will ultimately be assigned to one of our 4 designated informational classes. Let's add an imagery base map. This base map will help us to determine which spectral classes belong to a particular informational class. Let's look at this base map. It looks pretty similar to our natural color composite. As we zoom in, it changes to higher resolution aerial imagery, which we'll need to help determine the informational class for each pixel in the image. Now let me turn these back on, and I'll go ahead and zoom to that layer. For our first step, I'm going to change the color for any spectral class that has any of our final informational color classes of red, yellow, green, or blue to any other color. I'll just choose black. to eliminate confusion if any of the spectral classes were assigned by default to one of the colors that we're going to use. Okay, I think that's good. Now let's start with water. In our scheme, water is symbolized as blue. So let's zoom in to Smith Mountain Lake, which is over here, and choose a pixel to check its value. This shows its pixel value is 1. Remember, these pixel values are not associated with brightness values, but they've been assigned a classification value from 1 to 25 because we chose 25 classes. Now in contents, I'm going to find this value of 1 here, and I'm going to change it to blue. And I'm going to choose lapis lazuli for all water pixels. Now notice that all of the pixels in this image that are water have been changed to blue. So you can see the lake, you can see the river as it meanders north, but you can also see that parts of Smith Mountain Lake are other colors. So let's turn on the swipe tool. And as I swipe through, you can see that some of the pixels are water that we're looking at. Let's zoom in a little closer. So some of these pixels are still in the water. Let's turn off the swipe tool and click on one of these pixels. All right, so this is pixel value 2. I'm going to go change that to blue as well. So as you go through your process, check other water bodies. So you could go up to Carvin's Cove, you could go on over to this river here, and use the swipe tool to verify that those colors are also water within those water bodies. If yes, then change those pixel values also to lapis lazuli. Once you're finished with water, use this same process to continue with the other spectral classes, using the base map to help identify the land cover associated with each class. You're going to associate agricultural fields with yellow, forests with green, and urban areas with red. So now pause this video and finish evaluating and assigning your pixels to information classes. Okay, that took a few minutes actually. And now that you're done, I'm sure you have some questions. For one thing, we only have 4 informational classes to choose from, and as you've gone through this process, you may have noticed that it was difficult to make some decisions about what land cover you were looking at and which class you should assign it to. So let's look at one of the golf courses as an example. I'll turn this off for a second. So here's our golf course, and as I turn it back on, notice it has fallen into multiple spectral clusters. Here you see agriculture, forest, and urban, and maybe the water hazard was probably correct. And if we swipe through it, you can see that the major part of the golf course is considered agriculture, but right next door to it is urban. That big field is urban. So the question would be, should golf courses be classified as either agriculture or urban, or should you create a new category? Should tree canopy coverage in an urban area be classified as urban or forest? What about clouds or cloud shadows? How do you classify those? Well, you can see here that I actually added a 5th color, white, for clouds, but I didn't address cloud shadows. But notice as I swipe through this, where I identify clouds as white, tops of buildings are also considered white. So to more accurately classify this image, we should have at least 50 classes. Let's zoom back out to the layer and just look at this picture generally. So now that we've assigned all 25 spectral classes, look at yours. Do the informational classes generally look correct in the image as a whole? Do you have any blue areas that are not water? Let me point out something about cloud shadows and how you need to be careful. So I'm going to go to a cloud shadows bookmark. And notice here as I swipe through, oh, wrong image. That was the base map. Notice here as I swipe through, the clouds are white, but the cloud shadows are blue, and so they look like water in this image, but they're not. That is a shadow of the cloud that's above it. So you have to be really careful because mountain shadows and cloud shadows can mimic water. Do you have any urban classes that are actually in the water? You may notice as you click around that the answer is yes to all of these questions, which again tells us that 25 classes were insufficient to separate all of the spectral clusters into informational classes. Continue to spot check your results until you're satisfied with how you've set up your information classes. Now in contents, the symbology lists 25 spectral values, but only 4 colors that pertain to our informational classes. 5 colors, of course, if you've included a separate class for clouds like I did. Now let's reclassify the spectral classes into our informational classes. So let's go to the geoprocessing pane. I'm going to back out of the supervised classification method, and I'm going to search for Reclassify. And I'm going to choose the Reclassify Spatial Analyst tool. The input raster is the unsupervised classification layer we've been working with. Notice that the reclassification table expands and lists all 25 values under the Value and New column. We'll use the symbology of the layer as a guide to complete this table. So all values that are coded as red are urban, and we'll change those to 1 in the new column. All values coded as yellow are mixed agriculture, and we'll change those to 2 in the new column. All values coded as green, change to 3. All values coded as blue, change to 4, and we'll make the new clouds class 5. So for example, 1 here has the current value of 1, and its new value is, let's see, blue is 4, so we're going to change that to 4. 2 is also blue. We're going to change that to 4. 3 is urban or red. We'll change that to 1. And I'm going to finish this up and come right back. Okay, that took a bit. Notice that I have made the new clouds class 5. So as I scroll down, you can see under 25, which matches 25 over here white, I've made that, well, that should be 5, not 25. And the same goes for 22. There's 22 over here, and I've called it 5. So now that I've made these changes in the Reclassify tool, I'll accept the output raster name, and I'll run the tool. Okay, so you see the new layer in contents with randomly assigned color symbology. So let's go ahead and select that layer and go to symbology, and we'll change the color scheme and actually the labels too. So under the label column for value 1, so there's 1, we know the informational class is urban, so I'm going to type urban, and I'm going to change the color to red. Our symbol for 2, or a value for 2, is agriculture, and the color is yellow. Okay, now if you were to swipe through these two, you could spot check by swiping through. These two should look exactly the same. So if I turn the reclassification off, I shouldn't see anything move underneath it. Okay, so now let's calculate the percent of total area for each informational class. To do this, let's open the attribute table for the reclass layer. And notice that this table provides the count of the number of pixels assigned to each informational class. The percentage of the total area for each of these informational classes can be calculated by adding a field to the attribute table. Let's name the field %, and under data type, let's choose float. I'm tabbing over, by the way. Under numeric format, I'm going to choose numeric, and I'm going to ask for 2 decimal places. That should be plenty for a percentage. And OK. And let's add a second field for hectares. So I just have to click here, and I'll type hectares. I'll also make that a float, and we'll also make that numeric, and 2 decimal places. Okay, now that we have our two new fields, we can head on up to the Fields ribbon, save them, and close this table. Okay, notice I have two new fields now in my attribute table for the reclass. One is percent, one is hectares, and of course they have null values because we haven't given them values now. So let's go ahead and add those values there. But we have one thing we need to know before we can add that calculation is we have to know how many pixels are in the entire image to calculate the percentage for each informational class. So we could just get out a calculator and add up the count of all the pixels, but instead I'm going to right-click and visualize statistics. And in here we can see that the sum is 10,100,220. Okay, so now I have the information that I need. I'm going to go ahead and close this, and now I can calculate the field. So let's right-click the field here to calculate it and just use Calculate Fields. We're going to complete the expression for percent equals by typing a left paren, and we want that to be count, so double-click it. I'm going to divide by, and then I'm going to type in 10,100,220, and then that's going to be multiplied by, and I'm going to type in 100. And actually you probably don't need the parentheses, but I'm going to include them anyway because the book does, and I'm going to click on OK. Okay, so the new field now shows the percentage of the total for each informational class. Let's calculate the hectares field. And that formula is count. Let's just delete that. That formula is count times 900 divided by 10,000. And OK. So now we see the number of hectares that each of the informational classes takes up in the image. So before we finish up, let's discuss one option under the ISO cluster supervised classification geoprocessing tool that we did not use, and that's the output signature file. We didn't create this during our geoprocessing option, but if you enter a name here, saving a signature file generates multivariate statistics for each cluster. And the signature file can be read using any text editor, such as Microsoft Notepad. The statistics generated are related to the spectral values, not the information categories. They can be used to evaluate covariance between any of the bands within your multispectral image. This concludes this demonstration of unsupervised classification. How accurate was the ISO cluster unsupervised classification method with 25 classes? That's assessed in the last chapter of this book, Chapter 25, Accuracy Assessment. You can proceed directly to that chapter if you'd like to, but we recommend you complete chapters 22 through 24, covering the supervised classification process first.